All right, everybody, it's Durgett and Griffin again. We're going to show you how to simplify rational expressions. We're skipping over these three problems. We're assuming that you know how to do 15 divided by 5 and x to the fourth divided by x to the fourth. So you know how to do it if they're monomials. What we're going to focus on is the ones that are trinomials or binomials that need to be factored before you can simplify. This is the worksheet that we're going to be working on, working out three problems with y'all. I just said y'all. I am not from the South. All right, anyways, simplifying rational expressions. Rational expressions just means it's in the form of a fraction. So we've got a couple of different problems on this worksheet that we're going to work out. Here's our first one, and we're following the steps that are written at the top. The first one, so step number 1 is our problem. Step number 2 says write it in descending order. So here's our first one. If you look, I changed the order, put my x squared, my x, and my constant for the numerator, my x squared, my x, and constant for the denominator. Step 3 says to write it in factored form. So we've got to factor a lot. We've got the AC method here. What multiplies to give me, 40, and adds to give me 13. That would be 8 times 5. So we're going to do 2x squared plus 8x plus 5x plus 20. Group. Factor out of 2x. X plus 4. Factor out of 5. X plus 4. So this one factors into 2x plus, right over here. 2x plus 5 times x plus 4. Now I'm going to do the bottom part. What multiplies to give me 60 but adds to give me 17, and that would be, 12 and 5, I believe it came up with. So that goes 2x squared plus 12x plus 5x plus 30. Group. This has a 2x. This has a 5. So the bottom of this will factor into 2x plus 5 times x plus 6. A lot of work to do, and we're still not done. Now, step 4 says to reduce common factors. If we notice, 2x plus 5 and 2x plus 5 are the same, so they get to be simplified. Please don't assume that they go to 0. They simplify to 1 to exaggerate that. And my final step says to write the simplified form, which would be our x plus 4 over our x plus 6. Cannot simplify the x's, not when they are attached to binomials. That's only if it's in a monomial.
Number 2.
Dos. All right, here's our second problem. If you look, I've got x squared, x constant on the top, x squared and constant, so it's already written in descending order. We're just going to jump right into factoring. Please, please, please don't forget greatest common factors first. So we've got to take out the 10 out of the top, and then we get x squared plus 2x plus 1. Out of the bottom, we're going to take out the 5 and get x squared minus 1. And then we still have to keep factoring. What multiplies to give me 1 but adds to give me 2 would be 1 times 1. So the top factors into x plus 1, x plus 1. The bottom, if you look, is a difference of squares. So that's x minus 1 and x plus 1. Now I'm going to simplify my common. I'm going to do step number 5, which says reduce them. I got an x plus 1 and an x plus 1. Also, the 10 over 5 simplifies to 2 and 1. And then I'm going to finally write my final one, which would be 2 times x plus 1 over x minus 1. That would be my final answer.
Okay, number 3.
Number 3. Here's the original. We're going to write it in descending order, so I've got negative 6x squared plus x plus 15. The bottom's already in descending order, so we're good to go. Step 3 says make sure we factor out a negative 1 if our leading coefficient is negative. So we're going to do that out of the top. So that gives me positive 6x squared minus x minus 15. The bottom stays the same because that leading coefficient is positive already. Now we're going to do AC method. What multiplies to give me negative 90 but adds to give me negative 1 is negative 10 times 9. So this one is negative 1. 6x squared minus 10x plus 9x minus 15. First group has 2x, which gives me 3x minus 5. The second group has 3, which gives me 3x minus 5. We're looking good. So it factors into negative 1 times 2x plus 3 times 3x minus 5. Now we go back and do the bottom part. What multiplies to give me negative 45 but adds to give me 4 is positive 9 times negative 5. So that would be 3x squared plus 9x minus 5x minus 15. Group the first two, get out a 3x, gives me x plus 3. Group the second two, take out a negative 5, which gives me x plus 3. Looking good again, so the bottom of this is 3x minus 5 times x plus 3. Good, we're on to the last step 5, which just says simplify our common terms, which be the 3x minus 5. So I'm left with negative 1, 2x plus 3 over x plus 3. We leave it like that. I mean, if you want to knock your socks off and distribute that negative 1, go ahead, but that save yourself some time, and that would be your final answer.
Okay, number 12 on your rational expression sheet. Basically what I do when you're multiplying, all I do is I factor out each thing and I'm going to put it right above it, and then I'm going to simplify at the end. So if you look at x squared plus 10x plus 25, I'm using pink because pink's pretty. I'm going to go ahead and cross this out, and I know this is going to be x plus 5 times x plus 5. If I look at the denominator, I have x squared minus 9, and I know that is going to be x minus 3 times x plus 3. Now if I look at what I'm multiplying it by, I look at x squared minus 3x. I notice that I have a GCF of x, and then I'm left with x minus 3. And then right here I just have x plus 5. I'm going to rewrite that so I can just look at the pink stuff so I don't get confused. Now I'm going to look at the big picture. And at the top I have 2x plus 5s. And I have an x and I have an x minus 3. And on the bottom I have an x minus 3, an x plus 3, and an x plus 5. So I'm just going to cross off all the stuff I have in common because I know, like for example, x plus 5 over x plus 5 is 1. And I know that x minus 3 over x minus 3 is 1. So I can get rid of those. Well, I don't really get rid of them. They just go to 1. So at the top, I have left over x plus 5 and x. So x plus 5 and x. And on the bottom, I have x plus 3. And I would probably leave it like that. But if you want to distribute that x in, you can. But that'll be good enough. So that will be our final answer. Ta-da! Okay. If you notice on this one, we have two things here. We have a division sign. So if you remember, if we have 2/3 divided by 2/3, we know that's going to equal 1 because anything divided by itself is going to be 1. The reason that is because whenever we have a division sign with fractions, what we're going to do is we're going to keep this, we're going to change that, and we're going to flip this. So what we're going to do is we're going to multiply, instead of dividing it by the number, we're going to multiply it by its reciprocal. When I do this, 3 divided by 3 is 1, 2 divided by 2 is 1. That is how we end up getting 1. We're going to do the same thing with this problem. So what I would do is I would write down the original equation, minus 10x plus 25. I would change the division sign to a multiplication, and then I would flip this. So I have x squared minus 3x minus 10 all over 3x minus 12. Once I do this, I'm going to do the same thing as I did in the last problem. I know that x squared minus 16 is going to be x plus 4, x minus 4. I know that x squared minus 10x plus 25 is going to be x minus 5 times x minus 5. I know that x squared minus 3x minus 10 is going to be x minus 5x plus 2. And I know this has a GCF of 3, and I'm left with x minus 4. Now if I look at the big picture here, I have an x minus 4 on top and an x minus 4 on bottom. That reduces to 1. I have an x minus 5 on top with an x minus 5 on bottom. That reduces to 1. After that, I think that's all I can reduce it, so I'm just going to write down what I have. So I have an x plus 4 up top, x plus 4. I have an x plus 2 up top, x plus 2. I have an x minus 5 on bottom, x minus 5. And I have a 3. So that would be our final answer right there. Ta-da! Okay, for your homework, do this. The back side. All 10. And go.